This is a presentation for the CSA assignment on the topic interconnection buses, structures and its place in different types of computers. Bus. To describe a bus, it is a communication pathway connecting two or more devices. Buses are traditionally classified into three types: processor memory buses, input-output buses, and backplane bus. Input-output buses, backplane buses are the standard buses, while the processor memory bus is usually design specific, while input-output and backplane buses are also and often standard buses. In general, processor buses are smart and high speed. It tries to match the memory system in order to maximize the memory to processor bandwidth and is connected directly to the processor input-output bus. It usually is lengthy and slow because it has long range of input-output devices, and it usually connects to the processor memory bus or backplane bus. Backplane bus usually receives its name because it was built into the backplane of a computer, that is, it was interconnected with the chassis. It allows processors, memory and input-output devices to coexist on a single bus and has cost advantage of having only one single bus. The diagram describes the bus interconnection scheme in which different parts of the system, for example the CPU, memory, input-output and the bus are connected with each other using the control lines, address lines and the data line. This diagram describes the bus interconnection scheme where different system parts are connected in a bus using control, address and data bus lines. The bus system is not actually the big yellow buses we see, but small chips like the chassis and different bus line which connect different computer system boards.
Now I will tell you about bus structures. Now it consists of three lines. First is the data lines. Now these are the lines which provides a path between system modules. Now these lines are known as data lines. Now bus structure. Now since bus structure, it consists of three lines. First is the data lines. Now these are the lines which provides a path between system modules. These lines are known as data bus lines. Now remember that these data bus lines, they typically consist of 8, 16, 32 separate bytes. The number of lines being transferred to as the width of the data bus. Now each lines, they carry only one bit at a time. The number of lines determines how many bits can be transferred at a time. Now it increases the overall system performance which we need. Now the second type of line is address lines. Now these are the lines which are used to designate the source or destination of the date on the data bus. Now the second most feature of the address lines are the width of the address bus determines the maximum possible memory capacity of the system. Now like for example 8080 has 16-bit address bus giving 64K address space. Now which is a very important example. Now control lines. Now these are the lines which are used to control the case of the data and address lines. Now these lines include memory write, memory read, input output write, input output read, clock, reset, bus request and bus grant. Not only that, it also interrupt request and clock signals. Now we will talk about high performance bus. Now in this you can see there is a local bus, system bus, high speed bus and expansion bus. Now in this local bus is between processor and cache bridge. This system bus, it is between main memory and cache bridge. Now this high speed bus, it is between input output module and cache bridge, and this expansion bus, it is between low speed input output module and expansion interface. Not only that, this flowchart also consists of a processor, SCSI, PI394, graphic, video, LAN, fan, expansion interface, modem and serial. Now we will see how we can increase the bus bandwidth. In this, address and data can be transmitted in one bus cycle if separate address and data lines are available, but it increases complexity and also increases the cost. Block transfers. It allows the bus to transfer multiple words in back-to-back bus cycles. Only one address is need to be sent at the beginning. The bus is not released until the last word is transferred. The best feature about this, it decreases response time for the request.
Single bus problems, that why don't you prefer to use single bus? In these all units are connected in the same bus. which leads to propagation delays, as long data paths means that coordination of bus use can adversely affect performance, and aggregate data transfer approaches bus capacity. Therefore, multiple bus structures performance is better than single bus structure. That's why most systems use multiple buses to overcome these problems. Now, this figure shows that how buses are connected in our system and how it connects one component of system to another. It shows the interlinking of network and SCSI system computer system interface to the system bus, which connects our main memory to CPU and other components. Here, caches act like an intermediate between CPU and processor, which is connected to CPU by local bus. Now, I will tell you about the bus types. First, dedicated bus type are assigned to a single function, that is address bus, or to a physical subset of components. For example, input-output bus connects all input-output modules.
To drive.
Other one is multiplex bus. Multiplex bus can be used for both addresses and data. In this case, an address valid control line is needed to determine whether the data is an address or data. In this system, the number of signal lines comprising the bus is less than the number of bits of data address of the system. Now, I will tell you about the advantages of buses. It is easy to set up and extend bus network. We can add new devices easily. Cable length required for this topology is the least compared to other network, as a single sets of wires is shared in multiple ways. Moreover, bus topology costs very less. Now, here comes the disadvantages of buses. There is a limit on central cable length and number of nodes that can be connected. It is difficult to detect and troubleshoot fault at individual station. The maximum bus speed is largely limited by the length of bus, number of devices on the bus. Security is very low because all the computers receive the sent signal from the source.